In some problems, we're going to be given the focus and the directrix, the vertex and the directrix, or the vertex and the focus, and need to figure out the equation of the entire parabola just from that information. So we're going to practice that here. In this case, we're given the focus, which is 3, 1, and the directrix, which is the line y equals 2. So we need to find an equation. Technically, we don't need a graph to do this, but I find it's helpful to sketch a quick graph to let you know what I'm working with. So in this case, I plotted the line y equals 2, and I plotted the focus point 3 over 1 up. Since the vertex is always halfway between the focus and the directrix, I know that my vertex is going to be somewhere around here. So that's a good place to start. I also know that it opens up towards my focus, so it's going to open down. And we'll figure out exactly where it goes in a moment. But it's going to open down. So let's figure out how to calculate this now. Our vertex, if it's halfway between the point 3, 1 and the line y equals 2, we know that our x-coordinate is going to be 3 because it's in line here and it's directly above our focus. So we have that. And then our y-coordinate is going to be halfway between the focus y-coordinate, which is 1, and the directrix y-coordinate, which is 2. So the point halfway between 1 and 2 is going to be 1 1/2, or 3 halves. So our vertex then is 3 3/2. That's what I plotted right here. The distance from the focus to the vertex, so from the blue dot to the black dot, is just going to be using the distance formula. So all we're doing is we're plugging in the values to find that. In this case, since it's such a simple problem, and I can tell from the graph that these are 1/2 unit apart, I just did that in my head. If you wanted to use the distance formula, you could go from the point 3, 1 to the point 3 3/2, and you would get the length 1/2. So to calculate the distance from the focus to the vertex, we know that the formula is 1 over 4a. And since we know that 1 over 4a is going to be equal to that length of 1/2, we can set up an equation to solve a. So let's do that. So 1 over 4a, and it's written as the absolute value of a, I'll explain that in a second, is equal to that distance of 1/2. If we cross multiply here, we're going to get 2 equals 4 times the absolute value of a. Divide both sides by 4, and we're going to get absolute value of a is equal to 1/2. Now the reason we did this as absolute value is because I wasn't very careful when I took my distance from my vertex to my focus. I would rather do that a little bit sloppily, get that 1/2, and figure out what my sign is based on the direction of opening. Since I know my direction of opening is down, I know that I'm going to have to make this equation, or this a value, a negative 1/2. So when I get rid of my absolute value sign here, scribble that out, a is going to be equal to negative 1/2 because it opens down. So if I have a vertex and an a value, I can write the equation of a parabola in vertex form. Since it opens up and down, I'm going to start with y equals, not x equals. And in my parentheses, it's going to be x minus the x-coordinate of my vertex, and the coefficient out front is going to be my a value. So it'll be negative 1/2 out front times x minus 3. All the quantity x minus 3 is going to be squared. The coefficient is not squared. And then we're going to add on the y-coordinate of the vertex, so 3/2. So we're going to just add on that 3/2 at the end. And that's the equation of our parabola. See what this would look like. Let's go ahead and see this traced out here. This line, negative 1/2, is going to give it a fairly wide shape. It's going to pass halfway through between the directrix and the focus through our vertex, and of course always opening down. So one more example. This time we're given the vertex and the focus. So let's plot these out. The vertex is at negative 4, 4. That's going to be the black dot on this graph. And the focus is at negative 3 3/4, 4. So both of these dots, even though this is a fairly large graph, are very close together. And that is something you're going to get used to seeing quite a bit. So let's use the same general pattern that we used last time. So this time we already know our vertex because it's given to us, so we can just write that in and start working with the distance from our focus to our vertex. Visually we can see that if they are right next to each other and their x-coordinates differ by only 1/4 of a unit, then the distance between them is 1/4. And since 1 over 4a is also the distance, we can use that to solve for a. So 1 over 4a is equal to 0.25, or 1/4. If we cross multiply, 1 times 1 is going to be equal to a fourth times 4, which is also 1 times the absolute value of a. So we know that 1 is equal to the absolute value of a. Now, whether it's positive or negative, in this case, our graph, because it opens up towards our vertex, our graph is going to open up to the right. So I'll write that in. Opens right. And if it opens to the right, a is going to be positive, so we'll just keep a as equal to a positive 1, just like we have it here. Write that in to clarify. So we have our vertex given in the equation. We have our a value up front of positive 1. And since it's a positive 1 when we write the equation, we can just drop it. It opens to the right, which means that it's going to be defined for x, not for y. So we'll start out with x equals this time. And since, again, we had a positive 1, we're going to just throw that out and start with our parentheses. X minus the coordinate of our vertex, so x minus a negative 4, or x plus 4, excuse me. We're defining this for x. Don't make this mistake, like I almost just did. We're looking at now our y coordinate, because we defined it for x, so in the parentheses is the y. I came very close to making that mistake. Y minus 4, quantity squared. And we have our opposite of that value up there, plus the x coordinate, which in this case is negative 4, so we'll subtract a 4 at the end. And that's our equation. Again, always be careful when you have something defined for x and it opens to the left or to the right, that it's your x coordinate out front, or out by itself, and the y coordinate together inside of the parentheses.